Recording is rolling. Welcome to Friday, April 21st. Got some special stuff for you guys today. We're going to look at dark matter and dark energy. Got this TED Talk that I have to show every year because it's one of my favorites. There's a couple of mysteries out there in the universe you guys get to learn about. Okay, and I got something else lined up for you guys too. Right, so you guys know the last few days we've been working on those relativity puzzles and speed of light puzzles. So if you haven't turned these in yet, right, then turn this in pretty soon. Most of you guys already turned this in yesterday, right? And if you did, then I put the points in the grade book for you already. So those are there. Uh, you guys know that interim four is closing soon, or I don't know, maybe early teachers have told you. I think Monday in a few days here is technically the last day that could go into interim four. I don't think I'm going to put in any new grades here, so guys, double check, focus, make sure everything's in. If you're missing anything, then get it in Monday. I'm going to upload grades over the weekend for interim grades. But if you turn in something on Monday, then I'll go ahead and make an update. Okay. Okay. Oh, also electricity quizzes. Those are back in your folder, so they're there if you want them. All right, you guys good so far? Good so far? All right. So before I roll this video, I want to throw a question out here that's going to be answered in the video. But I want you guys to think about this. All right. So who knows? You can tell me. I bet somebody knows. How old is the universe? How old? 20 billion years. 13.8 billion years? Yeah, that's commonly cited number. There you go. Yeah, about 13.8 billion years, somewhere there. Okay. So if you look at the size of the universe as a function of time, okay, now people have known for probably about 100 years now that the universe is expanding. Okay? And we know it's expanding because we see distant galaxies are redshifted. In fact, the further away they are, the more they're redshifted, and then we can pretty accurately describe like how much the universe is expanding. Okay? But let's go back about 20 years ago, about the turn of the century. And there was a question, well, how exactly is it expanding? What is the ultimate fate of the universe? And there were three main hypotheses that were floating around. The first main hypothesis was, well, maybe if you rewind the clock, that's how you get to 13.8 billion years old. Right? So 13.8 billion years ago, there was some big bang, right? And then, but everything is gravitationally attracting. So maybe the universe is going to pull back together and end in a big crunch. Right? That was their first hypothesis. Right? Now that's sort of analogous to if you take a ball and you throw it straight up and it just comes back down. Right? But then that was, well, hold on a minute. You could take a ball and throw it straight up so that it reaches escape speed and just like flies away forever. That would be analogous to universe bangs 13.8 billion years ago. And then maybe there's this concave down type motion as there's gravitational attraction, but it should be, well, it could just keep expanding forever. Right? And then there is a sort of a middle option between those two, which is kind of analogous to if you throw a ball and it happens to orbit the Earth, which is, well, maybe the universe is going to reach an asymptotic size. Right? Like maybe bang 13.8 billion years ago, and now it's it's eventually going to reach like this limiting asymptotic size. Right? Those are the three main hypotheses for what's the ultimate fate of the universe. Okay? So again, within the last 20 years or so, different teams of astronomers have set out to answer that question: which of those curves are we on exactly? And they all independently of each other came to the same conclusion, which was none of the above. So like those are the only three possibilities that anyone was considering, and the result they got was actually a fourth possibility that no one had their eye on at all. Okay, you guys get that? So here, it's going to be a lights off day. Flip over, and we're going to watch this TED talk on dark matter and dark energy. Dark energy actually is where she gets to answer this question. And what's it? Oh yeah. Oh, the Fermi paradox. Yeah. Um, maybe in a not directly, I guess. Yeah, it's a different idea. Although, yeah, although maybe I did want to mention, which kind of ties into that too, sort of both of these ideas, is just how crazy big the universe is. Not just crazy big, but crazy old also. Right? You put those two ideas together, that connects to this, but also in a way tangentially connects to the Fermi paradox. Oh yeah, good. About 4.5 billion years old, and oh yeah.
So like it's the universe way more 3 times old.
There you go. There you go. Yeah, that's a good way of putting it, right? So however old the Earth is, right, multiplied by 3, that's approximately the age of the whole universe. Yeah, yeah. So, yeah, um, yeah, just how crazy big and crazy old the universe is. Nobody even knows how big the universe is because the fact that there's this expanding, and the fact that there's a limiting speed of light, like that Hubble Deep Field picture right there, that's like the edge of what's called the observable universe. It's possible that the universe goes on forever. There's a good case to be made for that, but it's a mystery. Right? A lot of mysteries out there. All right, so yeah, let me flip my screen over and we're gonna check this out.